Hey everybody, it's Mr. Carr again. Today we're going to be talking about 6-4. It's called the nth roots, which means we're going to be focusing on how to take a variety of radicals instead of just square roots. Okay, so real quick, let's look at the parts of a radical. We've got the index number, which is right here, and that could be any number we want except for 1. We got the radical sign itself, that's this one right here. And we got the number inside, which is called the radicand. Okay, the index number indicates how many of the same factors are required in order to take one of the factors out of the radical. So here's a few examples of that. Here, if I have a 2, which is the same as just without writing it, we're looking at how many numbers multiply together give me 64. Well, I want two numbers that multiply together to get 64, and that's 8 and 8. So therefore, the square root of 8 squared is the same as 8. If we look at 125, 125 is made up of 5 times 5 times 5. So when we evaluate the cube root of 125, since there's 3 of those, we can take that as the cube root of 5 to the third, which is just 5 then. Okay, so that's the goal when we look at these. Now we're going to make them a little more complicated. So we'll look at these right here. To help us with this, we're going to rewrite the radicand so that each factor, is raised to a power matching the index. Okay, and then we're going to simplify from there. So for example, even though it's invisible, that's a 2 there. So I want to write this as the plus or minus square root of something to the second power, as long as it does work out that way. And it does in this case. 16 is the same as 4 squared. X to the 8th is the same as if I take x to the 4th to the second power. So because I have that there, I've got the plus or minus. If I just evaluate this, I basically just get rid of my squared now with the radical symbol. So it'd be plus or minus 4x to the 4th. Okay, for the next one, same thing. I want to put something into terms of the third. So I want to take the negative cube root of something to the third power. Look a little bit weird, but 12, that's going to be the same. I'm going to actually have parentheses inside parentheses because that's going to be to the 4th power then. Okay, because if I raise this to the 3rd power, I get to 12. I multiply those together. This is just going to stay inside my parentheses there. So that'll be q to the 3rd plus 5. Now that I have it raised to the 3rd power, I'm evaluating that. I can basically, again, cancel that out. What I'm left with is this. So I'm going to take the opposite sign because I still need that there. So it's the opposite of q to the 3rd plus 5 to the 4th power. Okay, for the next one, I want to simplify that. Again, because it's the 5th root, then I want to take the 5th root of something to the 5th power. Okay, well, 243 actually is a perfect 5th root. It is going to be 3, because it's 3 to the 5th power. Gives me 243. For the a to the 10th, this has to be a squared inside. And for b to the 15th, that has to be b to the 3rd. And again, the goal is to match up this and this. That way they just kind of cancel each other out. So my final answer is just 3a squared b to the 3rd. Okay, so that's our basic ideas, but there's something else that pops up. So we're going to skip these right now. Okay, simplifying using the absolute value. When we have an even root like this, one of the earlier examples, we had an even root, but we had a plus or minus sign in front. In this case, as a quick example, like if I take the square root of, let's say, x to the 2nd power, we don't know if x is a positive x or a negative x. Okay, it could be either one right now because it's x squared. So a negative value would become positive, a positive value would still be positive. So because of that, we're going to say the absolute value of x is our answer here instead of just x. And I might be blocking that. Okay, so it becomes the absolute value of x. Every even root will do that. So when I take the 4th root of x to the 4th, again, this value can be a positive or negative. So because of that, when we evaluate the 4th root of x to the 4th, we don't want to just write x. We want to write the absolute value of x. So in this scenario, we'll do the same process that we normally do. Rewrite the radicand so that each factor is raised to a power matching the index, and then simplify. The only difference now is when we have an even root, we want to make sure we put the absolute value sign around our answer. So we want to take the 6th root of something to the 6th power. Now, you notice we got two things going on. We got 64 and we got this raised to the 18th power. So 4. I'm going to double check it, but it should be 2 to the 6th power. Yeah, 2 to the 6th power. Yep. So I'm going to put a 2 here. And again, that's 2 going to be raised to that 6th power, gives me my 64. I'm still in the parentheses here. And I want to make sure that this raised to the 6th power, or something raised to 6th power gives me 18. So that's going to be x squared minus 3 to the 3rd power. Again, everything is inside this to the 6th power. So 2 is raised to the 6th power, but so is this right here. Okay, so now I'm able to just cancel that out. So what I'm going to be left with is 2x squared minus 3 to the 3rd power, but the absolute value of that. Because again, this could be either number. It could be a positive or a negative number, and we don't know for sure. So we want to make sure we do we're saying the absolute value of this. Okay, so that leads us to our real world example here. Designers must create satellites that can resist damage from being struck by small particles of dust and rocks. Studies showed that the diameter in millimeters d of the hole created in a solar cell by a dust particle traveling with energy k is about this equation. So it's our radical function there. Estimate the diameter of a hole created by a particle traveling with energy 3.5 joules. So K is my joules. So that means that 3.5 is going to go right in here. So the diameter is equal to 0.926 times the cube root of 3.5, and then minus 0.169. Okay, so the biggest thing here is just making sure you know how to use cube roots in your calculator. Most TI-84s, you hit the math button, there's a cube root button there. But I'm just going to go ahead and do my order of operations. I'm just going to, honestly, I'm just going to multiply this all out and subtract at the end. Okay, so I'm just going to put it all in my calculator one time. So 0.926 times the cube root of 3.5. Okay, minus 0.169. All right, and I do that, and I get a diameter of 1.24 millimeters. All right, so for the next one, if a hole has a diameter, so we got D here of 2.5 millimeters, estimate the energy with which the particle made the hole was traveling. So we're going to say 2.5 equals, I'm actually going to add a page here because it's going to be a little bit more work. Okay, so I'm going to say 2.5 equals my function there. 0.926 cube root of K minus 0.169. Okay, so my solving process looks a lot like you've done in the past. The biggest thing is, how do I undo this? So we'll get to that in just a minute. So we're going to start it by adding 0.169 on both sides. Okay. So I do that and I get 669 is equal to 0.926 times the cube root of K. You can now divide both sides by 0.926. So I get 2.88229. We'll just use more on there. Okay, so the big key here is, how do I undo a cube root? We undo it by cubing both sides. We raise both sides to the 3rd power. Okay, so when I do that, I'm going to get my answer for K. So I'm going to raise that to the 3rd power there. And my K for my energy is going to be 23.94 joules. Okay, and that is it for 6.4. Okay, that's what we're starting with our radicals. We'll go more in depth in some of the future units on how to solve these, but that's a very basic start up for that problem. Okay, so again, radical, index, make sure those match up, and then you're just going to simplify. If we have an even index number, you're going to take the absolute value of your answer, not just the answer itself. All right, that's it today. Take care.